In today's video, we are going to compare RSTP, MSTP, and VSTP on a small switching lab. The topology is 4 switches. Switch 1 and switch 2 are the distribution pair. Switch 3 and switch 4 are the access pair. The reason we need MSTP and VSTP is that plain RSTP is simple, but it gives us only one spanning tree for the whole layer 2 domain. That means every VLAN follows the same forwarding and blocking decision, even when we would prefer different VLAN groups to use different paths. In a redundant topology, one uplink often ends up locked for the whole network under RSTP. If we can send one VLAN group to switch 1 and another VLAN group to switch 2, we make better use of both links, reduce wasted bandwidth, and create a cleaner load sharing design. MSTP solves that by grouping VLANs into smaller number of instances. So we get better path control without running a separate spanning tree instance for every single VLAN. VSTP gives us one tree per VLAN. That gives us the most control, but it also creates more control plane overhead because the switch has to process more BPDUs, maintain more protocol state, and make spanning tree decisions separately for each VLAN. I have already configured RSTP on all switches, configured 4 VLANs on the switches, VLAN 10, VLAN 20, and VLAN 100 and VLAN 200. Before we change anything, I want to show you why plain RSTP becomes limiting. For that, we will go to switch 3, we'll type show spanning tree bridge and show spanning tree interface. What we want to notice here is that one switch wins root for the whole topology, and one redundant path blocks for every VLAN at the same time. This is the limitation of RSTP. It has one logical tree for the whole layer 2 domain. Now let's convert the same exact physical topology into MSTP. For this, we will start on switch 1. First, we will delete the RSTP protocol, configure delete protocols RSTP. We will go into MSTP configuration, edit protocols, MSTP. Then we will create one MST region called lab. Set configuration name lab. Then we will configure the revision level. This revision level has to match on every switch in the same region. For this, we'll type set revision level 1. Then we will map the low VLAN group VLAN 10 and VLAN 20 into instance 1. Set MSTI 1 VLAN 10, set MSTI 1 VLAN 20. We will map the high VLAN group VLAN 100 and VLAN 200 into instance 2. Set MSTI 2 VLAN 100 and VLAN 200. Lastly, we will enable MSTP on the trunk links that participate in the topology. Set interface XC000, 1, and 2. Now we will do the same thing on the other switches. Show display set. I will copy all of this. I will add delete protocols RSTP, copy this, and paste it on the other switches. Commit. Before I paste it on switch 3, I will delete 002 because it doesn't have that interface. I will paste it here, commit and quit, and paste it on switch 4, commit and quit. Before talking about routes, we will verify the region itself. If the region does not match, the rest of the MSTP story falls apart. For this, we will type show spanning tree MSTP configuration. Here we want to see the region name is lab, revision is 1, the digest is identical on all 4 switches, and the VLAN to instance mapping is correct. If these don't match, MSTP configuration is going to fail. Let's look at another switch, show spanning tree MSTP configuration. As you can see, the region name, revision, and digest are the same. Right now, default priorities decide the routes. We are going to make switch 1 own the low VLAN group and switch 2 own the high VLAN group. For this, we'll go to switch 1. We'll type set bridge priority 4K. This will make switch 1 the CIST route. Then we will make it route for the instance 1 by assigning a lower priority. Set MSTI 1 bridge priority 4K. And for MSTI 2, we'll use 8K. Commit this and quit. Then we will do the reverse on the other side. Set MSTI 1 bridge priority 8K. Set MSTI 2 bridge priority 4K. Commit and quit. Now we will go back to switch 3 to confirm the changes. First, we will look at instance 1, show spanning tree interface MSTI 1 detail. Here we can see MST instance 1 points to switch 1. If we type show spanning tree interface MSTI 2 detail, we can see MSTI instance 2 points to switch 2. That means different VLAN groups can use different active paths while still staying inside one MST region with only a small number of instances. That is why MSTP scales better than per-VLAN spanning tree. Now let's move from grouped instances to per-VLAN spanning tree. For VSTP, we will remove MSTP, keep RSTP present as a fallback, and enable VSTP for the 4 VLANs we care about. The reason we keep RSTP on the switch is that VSTP is applied per VLAN. That means VLANs 10, 20, 100, and 200 will use VSTP, while RSTP can still protect anything we did not explicitly place under VSTP. So again, on all switches, we'll go configure. First, we will delete MSTP, delete protocols MSTP, then enable RSTP, set protocols RSTP interface XE000, 1, and 2. Then we will enable VSTP for the VLANs. Set protocols VSTP VLAN 10, 20, 100, and 200. And we will also enable VSTP for the interfaces XE000, XE001, XE002. Now we will copy all of this to the other switches. First, I will copy the RSTP config, show protocols RSTP display set. I will copy these here, paste it, show protocols VSTP set, copy the VSTP. I will also add delete protocols MSTP. I will copy all of this, go configure on switch 2, paste it, commit and quit. Again, we will delete the 002 interfaces. We will copy all of this and we will paste it into switch 3 and switch 4. Commit and quit, configure, paste, commit and quit. Now we will apply per VLAN priorities instead of per instance priorities. We will go back to switch 1, edit protocols VSTP, set VLAN 10, bridge priority 4K, VLAN 20, bridge priority 4K, and 8K for 200 and 100. I will copy these, paste it here, change the priorities 4K, 8K, 4K, 8K, and paste it on switch 2. Commit and quit, commit on the other side as well. This is the same design goal as before, but now we control the tree one VLAN at a time. We will go back on switch 3. We will verify that VLAN 10 and VLAN 100 can make different path choices. Go back to switch 3, show spanning tree, interface, VLAN ID, 10 detail. Now we should see VLAN 10 using switch 1 as root and VLAN 100 using switch 2 as root. So if I go to VLAN 100, we can see that it's using switch 2 as root. This is the advantage of VSTP. It gives more control over spanning tree by having a separate tree for each VLAN, but at the cost of higher overhead. So that was the full lab. We started with RSTP and saw one shared spanning tree. Then we moved to MSTP and grouped VLANs into 2 instances with 1 region. Then we moved to VSTP and got per VLAN control. Thanks for watching. See you next time.